Okay, so this is lesson 6. This is gonna be very casual.
Well, especially so since there's 2 people. So let's do this.
All right, I'm gonna be teaching about functions.
It's just a quick review because I think everyone that signed up for advanced already knows about functions.
Yes. Okay. So functions are basically a variable that stores multiple lines of code, right? And so if you have really redundant code, you can just put that into a function, and then you can repeat that over and over again. And so it's like similar to a math function. So if you have the function f of x, then it can return different data types, right? Or values. Next slide. So the special keywords that we have in functions are def, which is defining a function. So this is like initiating a function. The second one is return, right? So what do you want to return from the function? So all functions output a certain value, right? And so it can be a wide sort of thing. So it can be strings, arrays, numbers, pretty much anything, any data type of data, right? And then so this isn't really a special keyword inside Python, but it's just something that you want to know for vocabulary when you're talking to other people about it. So you say arguments or parameters. So like, what do you put inside the function, right? And so not all functions have parameters, right? You can just the function just runs by itself without any directions or anything. So for this example, right, if f of x is equal to 2x, right, that's the function, and I pass in the parameter of 2, then it returns 4, right? So that's pretty much it. So instead of saying, if you put it inside the function, you say the parameter is, or the argument is, it's a lot easier to talk about. And then so pass it's a filler word, basically. If you're writing a function and it doesn't have any, if it doesn't have any specific purpose, but you need to use it later, you use pass. So if you don't use pass, it'll identify it as an error. So it's kind of useful, but that's just for your comfort or benefit. I don't even know.
I need to do that.
Alan Yang, thank you for coming out. Okay, next slide. Okay, this is basically very, very easy. So making a function, def, my function, right? That's the name. And then you have parentheses, right? And then you have a colon, and then you print hello, right? And then so how you call it, or you execute that function, you just call it by copying the name and then the parentheses. Okay,
all right.
I'm going to show you.
I'm going to stop sharing
very quickly. I'll see it. Okay. So what we have is def my function, right? So this is how you define it, and you print hello, right? And the way you call it is my function. Oop. Right. And make sure you get your parentheses. Right. If I run it, right, it's gonna say hello. Okay. And so we're gonna have just a little nuances here. So we're gonna say define returning stuff, right? That's the name of it, and it's gonna say return hello. My name is Sean. Okay, so if I just execute this function, right, it's not gonna do anything, right? Because all Python sees is this function returning it, but Python doesn't know what to do with it. So what you can do is you can copy this and then print this function, and now it'll print it, right? So that's a little nuance thing. And then so now we're gonna have parameters. So define with parameters, and then you can name this whatever you want. So this parameter can be any number. And then so you take that same name, right? So I want to write a function that returns any number times 5. So you do any number, right? So you take this number argument, you multiply it by 5, right? And so what you want to do is, if you don't say return x, this function will absolutely do nothing. So you have to say return. You have to be very specific. So with parameters and 5. So this should print 25. Easy enough. And so here we go. I'm going to do a little bit more an advanced example. If you can hear my dog, I'm sorry about that. Anyways, so right. So I'm going to write a function that returns a random list. And then you do, I'm going to make an empty, what's it called? Empty list, right? So for I in range, 0, and then the length, oops, 0, the length of a random array. And then you're going to do x, and then you're going to use the append function, random.rand int, right? And it's going to take the inputs of a and b, right? So that's going to be the range, right? And so what you want to do now is return x, right? So now if I do return random list, then you do, let's say I want a range of 0 to 20, and then I want it to have a length of 10, right? So now it should print out this. Oh yeah, I forgot. Okay, yeah, you have to print this out. Sorry. Print it. There you go. So you have a range of 0 to 20 with a length of 10. Okay, now what I want to do is I want to do a little bit of foreshadowing. I don't know. So I'm going to define a function that converts the list, Python list, into a NumPy list. So I'm going to call it converter, and it takes the input of a Python list, right? So I ran out of ideas for this one, so I just named it bruh. All right. So if you want to convert it into a Python list, a NumPy list, then you do this, and you return it. And I'm not going to demonstrate it because you guys probably know this. So it returns the NumPy version of that. And what else is there? Okay. So now we can do this thing called parameter specification. So if you just put in like let's say you have a function with multiple parameters, right? So like school, name, age, right? And so what you would usually have to do is you would have to specify those variables in order. But I'm going to demonstrate how you can just do it in a different way. So this is useful for functions with multiple parameters, right? And then school. Don't break on me. Okay. And my name is name plus, and I am age, right? So now turn the string. Okay, so normally what you would have to do is like do print multiple parameters, right? So we would have to do it in that order. So let's say school, like Centennial, Sean, and on the 16th. And so if I run that, right, this is I gotta fix that, right? So I could do that, or I could do it another way. So what I could do then is I could specify it. So let's say I wanted to do name first, right? So let's say name equals Sean, and then school equals Centennial, and then age equals 16. Okay, so this is out of order, but even though, yeah, it's still the same logical sentence, even though it's not grammatically correct because I don't know, weird spaces. And so this is the final example. So if I have a function, right, and I don't know what to do with it, right? If I just leave that there, then it's gonna return a error. So what you can do is you could just write down pass, and it'll be like, okay, Python is just like ignoring this, and then it'll execute the code again. Okay, so that's a very quick overview of functions.
Okay, back to the slides. Okay, now we're getting into the new stuff. So we're going to be learning about libraries and how to install them in different IDEs. So since we use Replit and PyCharm, I'm going to demonstrate how to install libraries in both of these IDEs. So in Replit, let's just say, I don't know, here, you would get a library by going to the left and then click Packages, and then you would search for a library by typing in the name of it. So I just remove string color, and now let's say I try and add it back in. So I go type it in, and then I just wait for it to add the package. And then when this shows like a minus, then that's when you know it's done, or when there's nothing more in the console. So now when I go back, now it says string color is added in Replit. And then for PyCharm, let's say right here, you would go to the terminal. It's in the bottom left. And then, for example, you would see this, and then you would install a library by typing in pip3 and then install and then the name of your library. And again, like Replit, it'll take some time. Okay, now the first library I'm going to be talking about is called the random library. Like, I think it says itself in the name. So basically, the random library will return like usually a random number, or maybe in a sequence, and it'll return a random element. And here are some of the useful functions in the random library that can be used. So first there's randint, which stands for random integer, and they'll return a random number between the given range. And the randint function will take in two parameters, two integers to be exact, and it will include those integers. So if you do randint 1, 10, then it'll pick a number from 1 to 10, and 1 and 10, those are also possible return values. There's the choice function. It will return a random element from a sequence, like maybe a list or a tuple. There's the choices function. It'll return a list with the random selection. There's the shuffle function. It'll take a sequence and then return it in a random order than originally given. There's a sample function. It'll return a sample. And then the random function will return a random float between 0 and 1. And I don't really know if there's a good use for this, but I guess you guys let me know if you find something useful about it.
So sequence means list or?
Yeah, basically.
Yeah, okay.
So like, for example, here's like a demonstration of the random function. It's not very useful, but yeah, like this. And then maybe you could round it. And then here's the randint function. So like I said earlier, you could put in two integers as your arguments, and then it will return a random number from 1 to 10. So here it returns 8. Next is the random.choice. So I created a list called main list of all the board members. And this when I run this, it will return with a random name. So there's that. For the shuffle function, I'm using the same name list, so it should return the list in a randomized order. So like that. And then the random.choices, I didn't say this earlier, but it requires two parameters: the name of the list and also a variable with the integer assigned to it. So here, like if I'd say k equals 5, then it will return 5 people or 5 elements from the list. And I think they sometimes repeat themselves. So here it returns Sean twice. And then finally, the random.sample function. It's very similar to the previous one, the .choices function, but all the returned elements are unique. So like in this example, I'm still using k equals 5. So it's kind of a different way of the random.shuffle function. So all the elements in this list are unique. They're different than the random.choices function. Next is the datetime library. I think I went over this a little bit in the last lesson. So datetime function, it will just use like a date or a time and return it as an object. And some common functions are the datetime.now function. It will return the current time, and the time zone will, or the IDE will probably change the time zone. Like in Replit, it's UTC, so you have to manually change the time zone to EDT. There's datetime.datetime, and then you can put in 3 parameters like the year, the month, and the day in number form. And it will create the date. And next, there's the current underscore time. That's just a variable I used for datetime.datetime.now. And then you put in the variable. Oh, sorry. You put in the variable here, and then you type in the strf time function, and they'll format date objects into strings, and they'll take 1 parameter. And here's just a list of the kind of format you could use. So like there's just 1 letter, and it can be uppercase or lowercase, and they'll completely change what you get. So for example, like percent lowercase a will return the weekday in abbreviated. So it could be like WED, and then percent capital A will return the weekday and not abbreviated. So it'll return Wednesday, the full word. And then more or less the same thing with the case when it's case sensitive. So like this, so I have the same declaration of the current time variable. And I have the print datetime.datetime.now, or I could put the current time here. And you can also use this variable to return the year, day, and month separately. So if you put like .month, .day, or .year, it can change things up. So here it just prints the time in UTC, because Replit always returns UTC. And then these functions return the current time in number form. And then here are the examples of the format codes I mentioned earlier. So for example, like the day of the week is abbreviated, it's not abbreviated. The month is not abbreviated here. And then with this, this whole set of format codes, I created like the day today and the time format that we usually use, like with 0 to 12 as the hour, and with AM or PM, and then here it's from 0 to 24. And then the colorama library, this is mostly just to color text or make the background color. It's mostly just aesthetics. And the best way to access this library is by typing in from colorama. From the colorama library, import the for, back, and style modules. And then to use this, you'd print like whichever, I guess, kind of text you want to use, like foreground and the background or the style. And then you put in the color. I think the colors are kind of limited in colorama. Like it'll just say like red, yellow, green, blue, cyan, or stuff like that. And then here you put a plus and then whatever you want to say. You could say bro, you could say what the heck, or like, doesn't matter. So if you put the for module, then it'll return the colored foreground text. If you put back is in the print statement, then it'll return the background with color. And then finally with style, then you can return the text with the specific brightness. And then this function right here will reset the foreground, background, and brightness to normal font and color, just white. And also another alternative to the to the colorama library is the string color library, and there are a large variety of colors you can use if you want to increase the amount of colors you want to use. So like here, for example, the colorama library includes like a limited amount, and then here's the foreground, here's the background, and then here's the style. You can do it dim, normal, bright.
Okay, so this week and next week we are going to focus on a very important and one of the biggest and complicated libraries. Oh gosh. Anyways, so if you're a STEM student and you're looking for analysis, or just very, if you want more control over your variables, or you want extra speed for lists, and you want more math functions, this is for you. So NumPy is the standard math library. And you have to install this because the creators of Python didn't make it. A bunch of really cool dudes, they made it. And so what NumPy, one of the biggest advantages is that it uses an array instead of lists. So the way Python lists are coded, it's very inefficient. And so it takes a lot of memory up, and it's just overall very slow. And so instead, what NumPy did is they created an array instead of a list. Well, the concept of arrays always existed, but they just made the array version of Python. And so they're way more efficient and faster. You could look up the complex reasons why it is faster. It just is faster, okay, the way it's made. And so Python, you can compute. There's a lot of cool functions, like taking the cosine of all the elements of a list or an array, and then you can create 3-dimensional arrays, 2-dimensional arrays, 4th-dimensional arrays. I have no idea how that works, but for today, we're gonna look into the very basics of this lesson. So next slide. So this is standard, apparently. So what you do is you do import NumPy as NP. So NP basically just shortens. So if you want to access anything, it just shortens NumPy as NP, right? So if you do NP dot, you can access anything. And so this is a very basic function, right? So if you say np.array, you can pass in a list, and then you can create an array object, right? And so you can perform all the NumPy calculations onto this array, right? And so you can get the dimensions of the array. So yeah.
Those are just a few simple functions. It gets a lot harder from here.
Yeah. An array is it's just like a list. They're basically the same thing, but Python calls them lists for some reason. But arrays are way faster. So this is the basic way you create an array. So you do my list equals np.array, right? So then you have the function parameter as a regular Python list, and then the NumPy library will convert it into an array, a array. English. Okay, next slide. Oh wait, that's it. Okay. I guess I'm demonstrating now. All right.
Yeah. I'm gonna stop sharing.
Yep. You guys see it? Hello?
Not yet.
You guys see it now?
Okay, now.
You guys see it now?
Now I
Okay.
see it.
So you can make different types of data types. They for some of them I don't understand, but yeah, we can do it. So the first thing we're gonna do is we're gonna do Boolean. So you can just make it Boolean, right? Oh gosh. Okay, now it's working. And it takes a parameter of true or false, right? So that's how you initiate a NumPy Boolean. And then you can make a byte np.byte, and it'll take, so for a byte, the range is -128, right? Oh, -128 to 127. And so if I print this, right, print byte, watch this, 127, right? But then as soon as you go over the memory limit, it'll overflow to -128. Okay? All right. So for Python, memory management is a little bit of an issue. So if you're very low on memory, or you want to speed up your program, and every single line of code counts, you can be very specific on the type of variable that you're using. And this is typical practice for other languages like Java, C++, any other language, but Python is special. So you can use this to specify and reduce memory usage. Okay. And now we're going to go into the next ones. So the next one we have here is int16. So we have a 16-bit number, right? And so all you have to do is np.int16, and it'll take a parameter, and the range is from around -32,000 to 32,000. So I'm just going to write 32,000. And I forgot to print it, but we're going to move on. Okay, so int32, right? Do int.int32. And so for this one, the range is around -2 billion to 2 billion. So you can write 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's 9 zeros. That's a billion. And I forgot to print it again, but whatever. All right, so now we have int64. This is the big number, right? So we do np.int64. And the range for this one, I copy and paste that. The range for this one is this number. I'm not gonna say it out loud, but it's huge. So if you need some random, crazy amount of space, I don't even know. I don't even think this is the limit. Okay, so that's it, right? int64, right? So those are the this is definitely not all of the data types. There are way more, but these are the most simplest ones. And so we're gonna make a list now. So my list equals np.array, and then so now we have to pass in a list, a Python list. So when you print this out, I'm gonna print it. It actually looks kind of different compared to a regular Python list. You can see it doesn't have any commas in it. And so what you do to access the elements is just normal, right? Regular. So we'll take it, and then you have this. So it's the first element, right? 0, 1, so 2, right? That's how you do it. And so we're gonna go through the arange function, and this is kind of cool if you want to generate some if you want to generate very easy, if you want to generate certain types of lists very easily, then this is the function for you. So I'm going to do a basic range list. I'm going to create a function from 0 to 9. All right. So if you wanted to do 0 through 10, then you have to do, I forgot to print it again, right? Right, okay, print. Yeah, so it will generate a list from 0 to the biggest number minus 1. So if I wanted to do 10, right, then I just do 11, generate it again. Then it has 10 numbers, right? The spacing here looks kind of weird. I don't know what happened there. Okay, anyways, now we're going to do an arrange function with intervals. What I mean is that it's going to have a certain range, but then it's going to increase each number by a certain interval. So I'm going to range step list equals np.arange, right? So I want it from 0 through, let's say, 10, right? And then so I want to increase it by 0.5 each time it increases. So we're going to print it, range step list, right? And then it'll increase it. So it goes from 0, 0.5, 1, 1.5, 2.0, 2.5, 3, right? It keeps going up until 9.5, right? And I'm guessing if I do 10.5, then it'll go up to 10. Right, 10. Okay. And we could do this in the opposite way, right? So we have a decreasing list. I'm just going to make a decreasing list. We're going to do np.arange. And we're going to have it going from 10 to -1. So I want to go from 10 to 0, but you have to put it -1. Right? And I want it to decrease by 2 each time. But Python doesn't know that, so you have to specify whether it's going up or down. So I'm going to do -2. If it's 2, it won't work. So you have to print decreasing list. And then it goes on by 2 each time. So 10, 8, 6, 4, 2, 0. Very useful if you want to generate some nice lists. Okay, so now we're going to generate a 2D list. And so the syntax for this is kind of confusing, but I have a general rule for you guys. So if you want to do np.array, right? So the number of brackets determines the dimensions of it. So, all right, so we have parentheses, right? This is the function parameter, right? So I want to generate a 2D list. So what I'm going to do is I'm going to press the bracket twice, right? Very confusing. And then within those brackets, right, it's saying 2 dimensions, right? So I'm going to have one bracket, 1, 2, 3, right? And I'm going to have a comma, right? And then another one, 4, 5, 6. Okay, so now we just made a 2-dimensional array. Now we're going to print 2D list.
You can also use the pretty print library just to make it look better.
Yes. And so the way you access these functions, I mean, not functions, elements is through, it goes from row by column. So let's say I wanted to access right here, 4, this 4 number, right? How would I do that? So it's the first, so this is the 0th column, 0th row. This is the first row, right? This is the 0th column. This is the first row. It's kind of confusing, but it goes by 0. So if I wanted to access 4, it would be 1, 0. I'm pretty sure. I don't think I did this right.
Or it could be the other way around.
I don't know. Oh, that gave me an error. That's weird. Where's it 0, 1? Yeah, why are you not working?
I think just clear it. Clear the console.
Wait. How is it working? Oh, it works.
Wait, does it? Well, printed the smaller. So
Yo, I swear I'm tripping, bruh. Okay, wait. Let me copy this. Hold up.
do you have like an extra bracket?
Let's try this. I wrote this down late. I don't know what happened. Wait. So I have this array, right? It's a 2-dimensional list, but this time it's 2x3. So let's run that. I mean a 3x3. Sorry. So it's a 3x3. Right? I don't know what happened. Maybe I got the syntax wrong. I don't know. So what happened was I printed the 0th row, and then the first column. So it's 0. It's 2. This one. This is confusing. I don't like this. Pre-calculus got me messed up for arrays and columns. But so that's a very very basic approach to Python, and there's a lot of other things you can do. For example, like I could do print np.range step list. Oh gosh, this is laggy. Wait. And np.cosine, right? And it takes in the parameter of a list. Range step list. And so she'll take the cosine of each value, and it'll print it out. Hopefully. Yeah, right here. An ugly set of numbers, but yeah, it takes the cosine of it. So there's a lot of useful things you can do with this, but that's basically it. All right, now we can go back to the slides.
Yeah. Okay, so for the homework, it's basically just review again. Just review the slides and look into other libraries like maybe Selenium or tkinter. I guess those are just like some suggestions from us. And if you can, please install Selenium because I don't know, we might be using it in the next lesson. So you just need to type in like if you're using PyCharm, pip3 install Selenium, and then you need to download the Chrome WebDriver. I think we need to give you guys a website.
Just search up how to install Selenium for Mac, Linux, Windows, whatever. Because this is a huge pain to guide through people. So if you guys can figure it out yourself, that would be absolutely nice. We can teach you like automation for Python, so that'll be nice. And so you can for this week we didn't really have any ideas because we're just lightly touching each on the libraries. So you can choose. What you can do is you can create a blackjack program complete with the player and a dealer. Or you can create a program that count down the number of months, days, and minutes, and seconds until school starts. So very easy projects.
Oh, I forgot to say hours.
Yeah. So you guys can do that. Choose either one. And yeah, that's basically it.
Yep, happy programming.